Welcome back to RamZland. I'm so glad that you could join us for this lesson. Our hope in this lesson is to teach you how to multiply matrices and also to show you by comparing the row with the column if a matrix is definable or undefinable. So the first thing that a lot of people think about when they multiply matrices is they think of multiplying straight across, but that's not how you do it. What you want to do is you want to multiply a row by a column first. And so let me show you what I mean by what it looks like to multiply rows by columns. So if you have a matrix A here, and this is matrix B, the first thing that you want to do with these two matrices is to figure out if it's definable. And so you label a matrix by its column and row. So this is a 2 by 3 matrix right here, 2 by 3. It has and this matrix here, matrix B, is 3 by 2. And then what you do is you compare the row with the column between the two matrices. And if it's the same, it's definable. These are both 3. And so then you take this outer, these 2's, and you say, okay, then this is going to be a 2 by 2 matrix when you find the product of these two, okay? Now, if those two numbers right here and here, these are not the same, then it's non-definable. You can't do it. Let's take a look at an example of how to multiply matrices. Okay, so this one is 2 by 3. Let's figure that out as a 2 by 3 matrix. And matrix B is a 3 by 2. Now, do you see how these numbers are both the same? This column matches this row. They're both 3. So what that means is that our product is going to be a 2 by 2 matrix. Now, instead of just multiplying these numbers across, what you do is you multiply a row by a column, okay? So the first thing you're going to do is 2 times 1. And there it is, 2 times 1. And then you multiply the next number, 4 times 3. And you're adding it each time, 4 times 3. And then here's the 5 in the column. And you go 5 times 4, okay? And then the next thing you do is you do the same thing for the next column. So row by column, I'm still on the first row. Now I go to the next column and I have 2 times 6. Here's your 2 times 6. And then I go all the way down to 2 times 1, or I'm sorry, 4 times 1. Then I go all the way down to 5 times 2, and you see that right here, 5 times 2. I think I'm going to do the same thing for the next row, okay? So here's your next row. You have 7, and you're doing 7 times 1. And then you go to the next number, 8 times 3 plus 8 times 3. And then you go to the next number, 9 times 4. So I'm going to go plus 9 times 4. And then you got to do the same thing for the next column. So still on the second row, 7 times 6. I'm going to say 7 times 6 plus here's 8 times 1. And here's the next one, 9 times 2 plus 9 times 2. And then you'd simplify these, and you can see that happening right down here. So here's the 7 times 1, the 8 times 3, 9 times 4. That looks good. 7, 6, 8, 1, 9, 2. Okay, so 2 times 1 plus 4 times 3. So 2 times 1 is 2. 4 times 3 is 12. And then 5 times 4 is 20. Okay? So what they're doing here is they're just adding these numbers, and that's where they get this 34. So 2 plus 12 is 14, plus 20 is 34. Okay? And this next number, 26, 2 times 6 is 12, plus 4 times 1 is 4, plus 5 times 2 is 10. So 12 plus 4 is going to be 16 plus 10. That's where they get this 26 right here. And then they simplify the next row. 7 times 1 is 7, 8 times 3 is 24, 9 times 4 is 36. They're adding those 3 numbers, and that's how they get this 67 right here. 7 times 6 is 42, 8 times 1 is 8, 9 times 2 is 18. They're adding these 3 numbers, and that's how they get this 68 right here. So the thing to remember when you multiply matrices is it's row by column. 1 row by each column at a time. Let's take a look at another. Okay, so this is matrix A, this is matrix B. the first thing you need to know is if they're definable, if you can multiply them. So this one is 2 by 2, 2 by 2. And matrix B is 2 by 3. So remember, I'm comparing the row of A with the column of B, and they have to be the same. Those are the same. So I know that my matrix is going to be those outer numbers. My matrix then is going to be a 2 by 3 matrix. Okay? So if I work this out, you can see what they're doing here. They're multiplying the row by the column for each of these. So you have 2 times 2, there it is, and then you have 1 times 0. There's that, okay? That's the first column right here. So this column is shown right here, okay? And then I'm doing for the next column, I have 2 times 1, there's 2 times 1, and I have 1 times 2 right here. And that's right here, okay? Then they go to the last column, the third column. So I have 2 times 0 and 1 times 1. There's the 2 times 0 and the 1 times 1. Then you're doing the same thing for the next row. So I have 3 times 2 and 0 times 0. There's your 3 times 2 and your 0 times 0. Then you go to the next column. Here's the next column. 3 times 1 and 0 times 2. 3 times 1, 0 times 2. And then finally, this last column right here, you have to multiply. So I'm going to do 3 times 0 and 0 times 1. 3 times 0, 0 times 1. Then you simplify this to get your matrix. So I have 2 times 2 is 4, 1 times 0 is 0. I have 2 times 1 is 2, 1 times 2 is 2. These are being added. Then I have 2 times 0 is 0, and 1 times 1 is 1. Okay, so how do they get this 4? 4 plus 0. That's how they get that number right there. How do they get this 4? This is the middle one, 2 times 2. That's how they get that number right there. And the last one is 0 plus 1. There's the 1. Same thing down below. Let's try some of these on our own. So if you have a pen or a pencil, this is where I want you to try some on your own. Now this one here, B and A, are not definable. Why are they not definable? Because this is 2 by 3, and this matrix is 2 by 2. Notice that the 3 and the 2, when I'm comparing this column with this row, they're different. So you can't solve that one. I want to make sure it's definable. Okay, this one is definable. This is 2 by 2, and this is 2 by 2. So the middle numbers here, the column and the row between A and matrix B, are the same. So you can multiply that out. Okay, and this one doesn't exist. Let's look at a couple that we can do together. You scroll down to a few samples here. Okay. Okay. There we go. Okay, find the product. So I'm here, I'm looking at number 7. Okay, so the first thing I want to see if it's definable. This is 2 by 2, and matrix B is 2 by 2. So I can see that my column is 2 for B, and my row is 2 for A. And so I know this is definable, and this is going to equal a 2 by 2 matrix. Okay, so let's multiply it out for number 7. So row by column, so I have 1 times 2. And I have 0 times 1. So plus 0 times 1. Okay? Then I have to do the same thing for the next column. I have 1 times this 0 over here. And I have 0 times 3. Plus 0 times 3. Okay? Okay, so now I need to do the same thing for the bottom. Okay, so this is the top, this is going to be the bottom. So I have negative 2 times 2, negative 2 times 2, and I have negative 1 times 1. So plus negative 1 times 1. Okay, now I have to do the next column, row by column. So now I have negative 2 times 0, negative 2 times 0, and I have negative 1 times this 3 over here. plus negative 1 times 3. Okay? So now I have to simplify it. So I know 1 times 1 times 2 is 2, and I'm doing 0 times 1 is 0. So my first number is going to be 2 right there. Then over here, I have 1 times 1 is 1, 0 times 3 is 0. So my next number is going to be 1. Okay? And then for the bottom row, I have negative 2 times positive 2. Remember, negative times a positive is negative. And I have negative 1 times positive 1. So this is negative 4 plus negative 1. So negative 4 plus negative 1 is negative 5. And then over here, I have negative 2 times 0 is 0. And then I have 1 times 3. And I think, is that a negative 1? Let's find out. Negative 1, negative 2 times 0, negative 1. That's a negative 3. Okay, so I have 0 and negative 3. This is going to be negative 3 over here if I'm looking at that correctly. Okay, so this right here is your answer for number 7. That's the product of matrix A and B. Okay, let's take a look at number 4. And you're multiplying each one across. So I have 4 times negative 2. Let's do 4 times negative 2. And then I have 4 times negative 3. So plus 4 times negative 3. Okay? And if I figure that out, I'm going to have negative 8, and I'm going to have negative 12. Okay, let's take, and then I've got, I've also got, over here, I've got a 2. This is a 3 by 2. And this is a 2 by 2. So I'm going to compare the column from A with the row of B, and they're both the same. So this means my matrix has to be 3 by 2. This is going to equal a 3 by 2 matrix, okay? And for each one of these, I'm doing row by column for each one of these. And I'm going to need a little bit of space. I'm going to write down here. Okay. So the first row is going to be negative 3 times 1. So I have negative 3 times 1. And I have 3 times negative 2. So plus 3 times negative 2. Okay. And then I have to do the same thing for the next column here. So I have negative 3 times 0 plus 3 times negative 1. Okay, so this row right here is done. I'm done with that. Now I've got to do the next row by each of these columns. So I have 3 times 1. So I have 3 times 1. And then I have negative 2 times negative 2 plus negative 2 times negative 2. Okay? Then I've got to do the next column here. So I have 3 times 0. 3 times 0 plus negative 2 times negative 1. Negative 2 times negative 1. Okay? Now I'm done with that row. Last row. So I have 0 times 1. Okay? And then I have negative 1 times negative 2 plus negative 1 times negative 2. Okay? Now I have to do the next column. 0 times 0. Okay? And negative 1 times, so plus negative 1 times negative 1. Okay, so I have to simplify this to find my answer. And here we go. Okay, so over here I've got 3. I have negative 3 times 1 is negative 3, and I have 3 times negative 2 is negative 6. So negative 3 plus negative 6 is negative 9. And over here, I have negative 3 times 0 is 0, and 3 times negative 1 is negative 3. Okay? Remember, this has to be a 3 by 2 matrix. So here's my next row. I have 3 times 1 is 3, and I have negative 2 times negative 2 is negative 4. So 3 plus negative 4 is negative 1. So I'm going to put negative 1 here. And then I have to simplify this one. 3 times 0 is 0. Negative 2 times negative 1 is positive 2. So I'm going to put positive 2 there. And then for this last row, 0 times 1 is 0. Remember, two negatives equal a positive. So -1 times -2 is +2. And then 0 times 0 is 0. -1 times -1 is +1. Okay? So your answer for number 9, the product of those two matrices is this matrix right here, which is 3 by 2. Okay? All right, let's go down here and take another look at, I want to look at some 2 by 2 matrices with you. Let me look at some 2 by 2 with you here. Okay. Okay, so in this matrix right here, for number 1, I have 2 by 2, 2 rows by 2 columns, and this is matrix A. For matrix B, I also have 2 by 2. So remember, if the column of A matches the row of B, then it's definable. You can find the product. So I know that by these outer numbers, this matrix will equal 2 rows by 2 columns, okay? So when I multiply it out, remember I'm doing row by column. So first this row would be 0 times 6. So I have 0 times 6 plus the next number, 2, and I'm going down in the column, 2 times 3. Okay? And I have to do the next column, all right? I'm going to spread this way out. Okay, so here's the next column, 0 times -6. 0 times -6 plus 2 times 0. 2 times 0. Okay? So this row right here is done. Now I have to do the next row by column by column. So this row times this column, this row times this column, and then we'll simplify the matrix over here. So I have -2, and I'm going down. So -2 times 6 here, -2 times 6 plus -5 times 3. -5 times 3, okay? So I'm done with that column. Now I go to the next column, -2 times -6, okay? Plus -5 times 0. -5 times 0. Okay, so let's simplify it. So I know that 0 times 6 is 0, plus 2 times 3 is 6. So my first number in my matrix is going to be 6, okay? The second number is going to be 0 times -6 is 0. 2 times 0 is 0. So the second number over here is 0. Okay, let's take a look at this one. So I have -2 times 6, that's -12, and -5 times 3 is -15. So -12 plus -15 is going to be -27. And that goes right here. And then from my bottom right corner, I have -2 times -6, that's 12. And I have -5 times 0, that's 0. So this number here is going to be 12. And that's your answer to that matrix right there. Okay, so let's take a look at our next one. And we're multiplying row by column here. So I have -5 times 6, a negative times a positive. This one's really easy, is negative, okay? And then you've got, of course, your -5 times -3 is going to be negative times a negative is a positive. And that's going to go right here. And then you've got your 4 times 6 is 24. And you've got to do by column. 4 times -3 is -12. That's easier because there's just one column, one row. This one's a little bit longer. Again, matrix A right here is 2 by 2. And matrix B over here is 2 by 2. And that means that your answer, the product of these two matrices, has to be 2 by 2. All right, so let's find out what that is. So I'm going to do this row by this column and this column. All right, so let's do that really slowly. So -5 times -2, -5 times -2. Then my next number, negative 5, not times negative 3, but I'm going down. I'm doing this column. So negative 5 times 3 plus negative 5 times 3. Okay? Then I have to do the next column by the same top row until I'm done with this top row. Negative 5 times negative 3, negative 5 times negative 3, and then this negative 5 times this 5 because I'm going down. So plus negative 5 times this positive 5 here. Okay, so this row is done because I multiplied it by this column and by this column. All right, next row. So I do negative 1 times negative 2. And then I have plus 2 times 3. Okay, that's this column. Now I'm going to multiply this row by this second column here. So I have negative 1 times negative 3, negative 1 times negative 3, and then I have 2 times this 5 over here, plus 2 times 5. Okay, so now we just have to simplify that. Okay, and I have negative 2 times negative 5 is positive 10, and I have negative 5 times 3 is negative 15. So positive 10 plus negative 15 is going to be negative 5. Okay, then this next number over here, negative 5 and negative 3 is positive 15, and negative 5 and positive 5 is going to be negative 25. So if I have 15 plus negative 25, I'm going to have negative 10. Negative 10. All right, let's look at this number right here. It's going to go right here. So I have negative 1 times negative 2, that's positive 2, plus 6. So positive 2 plus 6 is going to be 8 for that number. Then this number, negative 1 times negative 3, that's going to be positive 3, and 2 times 5 is 10. So positive 3 plus 10 is going to be 13 right there. So we have negative 5, negative 10, 8, and 13. Okay, let's take a look at number 4 really slowly. So first, this is matrix A, and it's 2 by 2. Always define these before you try to multiply them, because some of them will be undefinable. And then matrix B is 2 by 2. So I compare this row with this column. They're both the same. They're both 2s. That means that these outer numbers tell me what my matrix looks like. It'll be a 2 by 2 matrix. The product of A and B will. All right. So let's find out what it is. I'm going to draw it really big over here so we can multiply it out slowly. So this row by this column and then this column, that's my top line. Okay. All right. So I have negative 3 times 6, negative 3 times 6. And then I have 5 times this 1 right here, plus 5 times 1. Okay. Then I have to do my next column over here. So I have negative 3 times negative 2, negative 3 times negative 2. And then I have 5 times this negative 5 down here, plus 5 times negative 5. Okay? So what I just did was this top row. I'm done with the top row. Now I'm going to do the bottom row by this column and then by this column. So I have negative 2 times 6, negative 2 times 6. Okay? Then I have 1 times this one right here, plus 1 times 1. Okay? And then I have to do the next column. Negative 2 times negative 2, negative 2 times negative 2. And then 1 times negative 5, plus 1 times negative 5. And then we want to simplify all of this into a 2 by 2 matrix. So I have negative 3 times 6. I know that's 18, negative 18, plus 5. So negative 18 plus 5 is going to be negative 13 for that top left number. Then the number that's right below it, negative 2 times 6 is negative 12 plus 1. Negative 12 plus 1 is negative 11 right beneath it. Okay, so the top right number, negative 3 times negative 2, that's positive 6, plus 5 times negative 5 is negative 25. So positive 6 plus negative 25 is going to be negative 19 for this top right number. Then I have negative 2 times negative 2, that's positive 4, plus 1 times negative 5 is negative 5. So positive 4 plus negative 5 is going to be negative 1. So your whole answer for that matrix is negative 13, negative 11, negative 9, negative 1. That looks good. Okay, let's take a look at this one. This one's a little bit different. So in matrix A, right here, it's a 3 by 2. That's a 3 by 2 matrix. And from matrix B, this is a 2 by 2. Is this definable? You'd say, yes, it is, because this column matches this row. The inner numbers are the same. This is a 2, and this is a 2. The outer numbers tell you what your answer should look like. So it should be a 3 by 2, a 3 by 2 matrix. So again, I'm doing row by column. This row by this column, this row by this column. So let's do that together. So I have 0 times negative 4 plus 5 times negative 2. Okay. Then I have to do this row for this number over here. So I have 0 times 4 plus, that's a 4, plus 5 times negative 4. Okay. So what did I just do? I finished this row by multiplying it by this column and by multiplying it by this column. I like to cross out the rows as I go. All right, so let's do row 2 by these two columns. So row 2 is negative 3 times negative 4, negative 3 times negative 4, and 1 times negative 2, plus 1 times negative 2. Okay, now I have to do the next column. So I have negative 3 times positive 4, negative 3 times 4, and I have 1 times negative 4, plus 1 times negative 4. Okay, so I just did this row. Now I'm doing the bottom row by each of these columns, by both columns, okay? So I have negative 5 times negative 4, okay, plus 1 times negative 2. Okay, now I have to do the next column. Negative 5 times positive 4 plus 1 times negative 4. Okay, so now we want to simplify this. What should it look like? It should look like a 3 by 2 column, okay, a 3 by 2 matrix, I should say. All right, so let's look at that top number here. I have 0 times negative 4 is 0. I have 5 times negative 2 is negative 10. So this top number right here is negative 10. Okay, the next number, 0 times 4 is 0. 5 times negative 4 is negative 20. So this number is going to be a negative 20. Now I have 2 more rows to do. So I have negative 3 times negative 4, that's positive 12, plus 1 times negative 2 is negative 2. So 12 plus negative 2 is 10. And then my next number, negative 3 times 4 is negative 12. 1 times negative 4 is negative 4. So negative 12 and negative 4 is going to be negative 16 here. And then my last row, when we simplify it, negative 5 times negative 4 is positive 20, plus 1 times negative 2 is negative 2. 20 plus negative 2 is 18. Negative 5 times 4 is going to be negative 20. 1 times negative 4 is negative 4. So negative 20 plus negative 4 should be negative 24. And that's the product of those two matrices for number 5. Okay, let's look at number 6 together. I've still got a little bit of time with you. Okay, so let's look at matrix A, this one right here. It's a 2 by 3 matrix. Let's look at matrix B. It's a 3 by 2. Is this definable? Yes, because the row from one matrix matches the column of the other matrix. They're both 3. The outer numbers tell me what the product should look like. It should be a 2 by 2, a 2 by 2 matrix. That's how I should write my answer. Okay, let's simplify this slowly. First row, so I have 5 times -4, 5 times -4. And I'm going to add that with 3 times -3. Remember, I'm going down. 3 times -3. Okay. And 5 times 3 plus 5 times 3. Okay. Now I have to do my next one. Okay. So over here, I've got 5 times 2. That's a 2. Plus 3 times 4. Plus 5 times this -5. 5 times -5. Okay, that's my first row. Okay, now I'm done with this. I'm all done with this row. So I'm multiplying this row by this column and by this column. Okay, so I have 1 times -4 plus 5 times -3 plus 0 times this 3 right here. Okay. Then over here, I'm going to do this row by this second column right here. So I have 1 times 2. And then I have this 5 times 4 plus 5 times 4. And then finally I have my 0 times this -5 plus 0 times -5. Okay. So now we want to simplify all of that down here. Okay, so let's figure out what this is. So 5 times -4, let's see, that's -20. 3 times -3 is -9. 5 times 3 is 15. So -20 and -9, that's going to be -29. Let's simplify it this way. -20 and 15, that's going to be -5. So -5 and -9 is going to be -14. So this top left number is -14. Let's look at this one. I have 5 times 2 is 10. 3 times 4 is 12. 5 times -5 is -25. So I know 10 plus 12 is 22. Minus 25 is going to be -3. So this number here is going to be -3. All right, let's simplify the bottom row. So I have 1 times -4 is -4. 5 times -3 is -15. 0 times 3 is 0. So -4, -15, and 0 is going to be -19. And then this row, 1 times 2 is 2, 4 times 5 is 20, 0 times -5 is 0. So 2 plus 20 is 22. So for number 6, your matrix is -14, -3, -19, and 22. That's correct. Okay, so I want to review what we went over today. It's a lot, okay? So we went over, first of all, what a matrix is and how to label it column by row. And then we found out when you multiply matrices, you're multiplying rows by columns, but you have to make sure that they're definable. So you have to compare matrix A to matrix B and make sure that the column of one is the same as the row of the second matrix to make sure that they're definable. And if they are, then you multiply row by column. And after you've done that, you simplify it to find out what your product of those two matrices are. I'm going to post this on YouTube, on our YouTube channel, and I would highly recommend reviewing it because this is one of those things that you're going to use on a math test, but you're probably not going to multiply matrices, you know, in real life or anything else. So I would recommend reviewing this at your leisure. So good to see you guys. Our next class won't be until next Monday, same time, and I'll send you a link for that, okay? Have a great evening. Bye-bye.
Bye.
Bye-bye.